How heavy is this box? How heavy is the box? Let's find out. This is a pallet jack. As I pull this handle, it cranks the box up into the air. Let's see how much. First, I will set this at some number. Let's set the middle of the green line at 4. Now we're going to take this ruler and I'm going to move it. So let's get it to the point where this starts to pump right there. And let's move it a wee bit more. 33. Alright, let's subtract 12 from that. Moving my handle. So 23, 22, 21, more or less. Let's see what happens to our number. Oh, let's put it on the floor. So it moved up about 1/8 of an inch. So we don't know how much weight we did. We know we moved about 12 inches on that handle and 1/8 of an inch actual rise of the box. So I'm going to go with this formula that the distance times the weight will equal the distance times the weight. Well, what is the weight that we use to lift this handle? What can we use? Let's use this to help as a roller, somewhat friction, less friction. And we're going to put it on that piece of tape and try to lift some water. And I got one filled, but not the other yet. Let's see where we're at. Can that pull the handle? No, it cannot. See, no movement yet. Well, let's add a wee bit of water. Yeah, better use a funnel. And this is called a powder funnel because the large diameter nozzle lets powder travel freely, but it works for water too. Add a bit of water. And let's see where we're at. Oops. Well, I think I could barely move it, but maybe a wee bit more water to prove it. Let's not slip up here. So that's our rotating wheel. So if this comes straight out and that goes straight down, it should be just transmitting the poundage to that handle. Yeah, I'd say we're able to pull that handle just about right. It's the amount of pounds needed to make that handle go back. All right, let's go get a weight measurement. Taking me a few hours here to untie all this. So I'm just untie this in the interest of time. If I could even untie this. Go back and see how much this weighs. Get ourselves a scale. Currently reading 0 grams. Let's put that on there. I believe that says 5,300 grams. Well, looks like our units are going to be grams. So we moved it 12 inches times 5,300 grams. All right, let's just do the math. So we have 1/8 of an inch rise times the weight of the box equals 5,300 grams times 12 inches. Alright, let's multiply both sides by 8 to make that 1/8 disappear. And we have 5,300 times 12 times 8. Alright, in the interest of doing math in your head, let's round that off to 5,000. 5,000 times 12 would be 6,000. 6,000. Sorry, 60,000. Because 5,000 times 10 is 50,000, and then 5,000 times 2 is 10,000. You add it up, 60,000. Now if we were to take that extra 300 and times it by 10, you'd get 3,000. So let's go with 53,000. And then we have to multiply that finally by 8. 8. So 50,000 times, well, 3,000 times 8 is 24,000. And then 50,000 times 8 would be 400,000. 400 and, let's round it to 420. So 420,000 or 420 kilograms. And if we turn that into pounds. I think there's 2.2 kilograms for, well, we'll just be happy with kilograms. So this is a rough overestimate of the box. So there's definitely some friction involved in this system, which would make you have extra weight to overcome some friction in the hydraulics. So this is coming out with a mass of about about 900 pounds box, but the reality is I don't think that box is more than 500. So much for this technique. It's not ideal unless you want to pay a lot more for shipping. However, it might give you an upper end. You know your box is under 900 pounds. Thanks for watching.